Good morning, everyone. I'm just like to show off today this request system that I've been working on for Satisfactory. This is a factory based on a single megabelt with combined priority mergers and smart splitters. The key part for me was I wanted to be able to plug any sort of process into this belt, just consume items and produce them when needed. But then the problem with that is how do you not flood these belts, or you end up needing millions and millions of belts wide. And it's part of a series of stuff that I've been working on to try and create sort of modular style factories that are expandable, but also not caring about the actual specific throughput of things. I don't want to have to sort of sit down, do a whole bunch of maths, because then every time you reconfigure something, you've got to redo the maths and everything else. So I'll sort of walk you through the process. There are a few issues still remaining with the system, but hopefully this will give you a good overview. So if we start at the sort of core of the system, this is what I'm calling the production overflow control. And essentially what this is doing is it's taking the production item and it's looping it infinitely. There is a small bug in the system that whenever there's a lag spike, this does get tripped. As you can see, there are a few items that leak through even when the system's not running. But essentially there is an input here for a request. When the request comes in, it blocks this belt temporarily, which causes an overflow, and then the in this case concrete goes out onto the main production line. Now, if we just had a single request a single item, which is possible, that's not a problem, but the problem is that if you want 5 belts of input, you would need 5 control belts, and that seemed not sustainable. So we've got 2 systems running here, because I made some adaptations later. So this is the first system I designed, which is just a simple multiplier. So this basically is a 27:1. So when the item comes in here and it gets filtered out again, it goes through this sort of like those old the marble computers where it sort of flip-flops the gate back and forth. So only every 27th time that this looped around will it actually exit the loop and return back on the return belt. So that's a pretty simple system, but the problem I had with it was that when I had production lines like this one here, where we're using the iron and copper recipe in the foundry, you see here that it's a 40 iron a minute, but it's only 10 copper a minute. And the way that the system works is this request runs along this belt and it's filtered out by this one here, the programmable splitter. As you can see here, that steel ingots require iron ingots, but they'll also require down here the copper one will also require the steel ingot request. And so what that means is that if I'm requesting for the materials needed to make which one? So this iron ingot, I'm going to request the same amount of copper ore as I am iron ore, and that leads to a problem where I have to request the maximum amount I need, but then I end up with 4 times as much copper being requested as necessary, and most of it just goes into the sinks at the end of the line. So that wasn't great, but it was functional and it did get me past the first part. So then the second system I built was this one, and it's a lot bigger, and I've got to do some work on compressing it yet. But the key part here is that these programmable splitters on the bottom, which means that for individual recipes, so you can see here iron ingot, I can control the rates. Now it's not perfect. In this case, you can set it to only 3 times or 9 times the other recipe. So with iron ingots, I've got it set to 3 times, so that means it's going to request 40 iron ore, but it'll request 13.33 copper, which isn't perfect, but better than what it was. I can do some more work on this, so we can get some multiples of 2s and 3s, but this worked for now and improve the efficiency and the reduction on the line. So the request comes down the belt, it goes through the system, it blocks this, it sends a request, it goes through however many times, and then returns on the return belt, where it'll get filtered out by one of these smart splitters and then sent into the request buffer. Now we essentially needed a way of detecting when an item was consumed. And so all I'm doing is I'm using these requests and I'm putting them into this system. And what this system does is it's a bit like a sushi belt uh, inserter. So for every 26 items of iron ore, you'll get one piece of iron ingot. And then the iron ingot is filtered out by the smart splitter here, so it doesn't actually go into the production line. But essentially, there you go. We get a detection of every time 27 iron ore is consumed, and then that goes, as I said, up onto here, and then over to here, and then into the request line where it heads back down the line. So that's the basics of the actual request. Then this is just sort of a generic, manifold-based production line based around 480, because that's the belt size I'm using, and then that goes into the buffer, and then we're back at the start again. There is easily the capacity for this to do multiple production lines at the same time, which is something I was going to test later today with wire, because the input is only 480, but the output is multiple lines. But there's no reason why you can't stack multiple of these loops and then sort of have the request trigger multiple of them. And then that would allow more than a single 480 flow into the megabelt, which should deal absolutely fine. The megabelt itself is literally just 5 belt lines with a priority merger feeding in from a smart splitter, so it'll try to put it on the first belt first. You don't actually have to do this, you could just use a normal splitter, but I kind of like the fact that it shows me that it counts the belts as we go, so I can sort of see the capacity really easily. This is easily expandable, you just add more belts and another set of these mergers along the line. And then the other side is the smart splitters, which are just picking items off. So again, it doesn't matter which belt it's on, it'll get pulled off at whatever capacity it is. I'll trigger some of the items now, just to show what it's like when it's running. Again, at the moment, all that's doing is this leak is causing a few items to flow down. But here I've got the steel pipe factory. So if I delete these items out of here, we can see that the steel pipes are being consumed off the line. The production is beginning, which then means that steel ingots and concrete are being used. Now I've used the trigger for the steel ingots because they are slightly higher, and I haven't used any multipliers on this recipe because again I only have 3 times available at the moment. It's not that high. So as the steel ingot is being used, you can see there a request has been sent for the items required to make steel pipe. Now I ran out of space, so I turned a corner, so this is a little longer, this section of belt, and it's not the prettiest, but again, for the purposes of working this out and planning stuff, it's fine. So following the steel pipe down here, we can see it's going to get pulled into this, and you see the concrete stutters for a second, and then spits out. You can see the requests going through the feedback system at the moment. So they're first just bouncing around this one, then sort of bounce here, bounce, and they'll go around, as I said, 27 times in this, and then eventually they'll get fed back onto the request line, because they continue down the request line because you don't know how many other items are going to request it first. So hopefully after 27 loops, and it doesn't matter the fact there's multiple requests on the same belt. Yes, one item may go through 27 times, and the other one might go through and everything's been set up perfect and it goes straight through, but then what will happen is it means that the other item has to go through 27 times again, so it still ends at the same. So we saw a steel pipe one go through here. Continue on, and you can see the concrete is now starting to be requested as well as it starts to consume here. So these requests keep travelling down. So you can see steel ingots are now being dispensed onto the line. And then further down we can go look at the limestone, where the concrete requests are sort of looping around, and should be requesting more limestone. There's also water requests as well. Now for liquids, at the moment I'm using packaged liquids. All of the inputs work exactly the same, except for obviously they don't have an input section, just the output control loop. And then they're into these storage containers. I'm not quite sure what I'm doing with empty packages yet. It is possible that we could just bin them and then just produce on site for the production. I'm going to show the messy side now, but down here what I'm doing currently is I'm taking the emptied packages and just feeding them along here, and then they're going into some container storage with a priority based array, so it's going to use the existing empty containers first, and then if there's any missing it'll refill them from this little package factory that I've built down here. And this means that there's always going to be a flow of water, and I've got 3 more lines for oil and any other liquids that I might want to bring across. I think that kind of covers it for now. As I said, the 2 big systems that I need to work on are this multiplier here. Sorry, no, this one here. It's the old one. Where's the new one? There, this one here. And improve the sort of ability to select while also trying to compress it, because the faster these requests can go around the system, the better this rate will be. It can run up to full capacity, or nigh on full capacity. Obviously we're inserting at 1/27, so on a 480 belt you technically lose a small amount because you can't run all the items. So it essentially puts your belt down to 462. But otherwise it can request at full rate, and if you run out of an item, for example, then the requests just get spammed through, and that works absolutely fine, and it's held up to that. So it really is just a case of, can we request the right balance of items to try and prevent the flow? And then also, if anybody has any idea about this leakage problem, why occasionally this loop stutters and spits out an item, that'd be really helpful. I'll try and post the blueprints that I've got for this so far with a link to this video, so you can have a look and see the systems yourself. And if you've got any questions, please do reach out. Cheers.